Welcome to the Algebra 2 Semester 1 Unit 4 Study Guide. These words are all found on Quizlet. Please make sure that you have a Quizlet account. You should be in there at least 5 to 10 minutes a day playing games and making sure that you're getting this vocab down. That's the entire time that we work in a unit. So if you got behind, you should make up some time, spend a little bit of extra time. Okay, next page here. I'll be honest, the test that you're taking won't be multiple choice and it won't quite look like this. It's going to be a lot more open-ended. But I want to go through these, make sure that you have the concept down. The graph of which the function has a reflection. Remember, a reflection is a negative in the front. Y equals negative a, and then it's x minus h squared plus k. So the reflection is this negative there. A vertical stretch means that this a value, the absolute value, needs to be greater than 1. So let's look at these. This is a negative, that would be a reflection. 3 is greater than 1, so that one works. Now this 0.3, that's not greater than 1, is it? So that's the problem. That one's out. This one, both of these, similar to the other ones, that would be a stretch, that would be a shrink, but neither of them have a reflection, so they're out because they don't have reflection. Getting you ready for the final, get used to writing exactly what's wrong with the incorrect options. Okay, what is the value of f function of negative 2? All you're doing is plugging in negative 2 for your x value. So negative 2 plus 1 squared. Negative 2 plus 1 is negative 1. Squared is 1. 1 times negative 2 is negative 2. Minus 5 is negative 7. Show all the work. Make sure that you're doing that, getting ready for the final. Next one, it says, which of the following quadratic functions has a maximum greater than the function whose graph is shown? Well, here's the maximum here. The maximum, remember, is the vertex, and it's the y value of the vertex. So our x value is negative 2, but our y value is 4. So our maximum's 4 here. Well, we can look at these, process of elimination. We know if they're in vertex form that it's the k value. That one's at negative 1. And it's not even a maximum. It doesn't even have a negative out to the front, so it's out. This one would be at 0, and again, it doesn't have a maximum. It doesn't have a negative to the front, so it's out. These are both drawn as minimums. They can't have a maximum greater than that if they don't even have a maximum. And this one, it looks like none of these have a maximum, and I definitely say which of the quadratic functions has a maximum greater than. So this one is the same as, this one is greater than, but it is a minimum. So it would be our closest answer. I'd mark that, and then I'd come up here and say minimum greater than this maximum. I think that's a typo. Okay. Hopefully it's not the way in your test, but if it were, then take care of it. Okay. What are the zeros of x squared minus 2x? Well, zeros means that we set it to 0, and then we look for product property, zero product property. We can factor out the x from both. So we would have 0 equals x times x minus 2. Now we set each of these to 0. So x equals 0, that's one option. So that eliminates those two right now, because they don't have zeros. X minus 2 equals 0. We add 2 to each side, and we have x equals 2. So there we go. Okay. What is the axis of symmetry on this graph? Well, remember the axis of symmetry is the line that splits the graph right in half. And we know that this is an intercept form, so we know that this x-intercept would be -5, 0. And this one would be -1, 0. So where they cross the x-axis is -5, -1. So we'd have to find halfway between those. This would be -2, -4, -3. Another way that we could find that is take -5 plus -1 and divide by 2. That would be -6 divided by 2 would equal -3. Number 6, which of the following describes the graph? And here it goes. Well, let's just go up here and describe it. First off, we have a reflection. So let's check our options here. How many of them have reflection? I see reflection here. I see it here. I do not see it here. So that one's out. I do see it here. Okay. Next thing, we've got a factor of 2. If it's bigger than 1, we know it's a stretch. So it's a stretch by 2. So we go here, stretch by a factor of 2. That's good. Stretch by a factor of 2. That's good. Stretch by a factor of 2. So all of those are correct. Now we see this. Remember, in the H, it goes the opposite of how it looks. So instead of going right to, it goes left to. So, translation right, that's incorrect. Oh, translation left to, that's good. Translation left to. So we'll mark out this one that said right. And now we go to the ones that say left. And our k value, this +6, means up 6. And here we have up 6 units, up 6 units. Are these identical? It certainly looks like they are, so I would circle both of those. Circle both, they're both correct. Don't feel like a multiple choice with multiple answers is incorrect anymore. We like to do that on all sorts of multiple choice tests. So be prepared that it could be more than one. Okay, this says what is the minimum value? Well, if you remember right, the minimum value is at the vertex. So we've got to find the vertex. And the minimum value is that y in the vertex. So this is in standard form. We know that this value is your axis of symmetry. Standard form axis of symmetry has a formula. -b over 2a. This is my b, this is my a. So -10 over 2 times 5. That would be -1. Now, all that I need to do in order to calculate my y value of the vertex is to plug that -1 in. -1 squared is 1, so 1 times 5 would be 5. -1 times 10 would be -10 plus 10. 5 minus 10 is -5. -5 plus 10 would be +5. So my minimum value is at +5. Okay. Which of the following functions does not have the graph shown below? Let's look at our vertex first. This is at -3, -2. So if we go down to our vertex form, this looks like -3, -2, because that would be the opposite, and it also has a stretch value of 2. So that one does. We're looking for the one that does not. So that one does fit. Now we go to x-intercept form. We have +4 + plus 2, so remember, the x-intercepts would be negative 4, 0, and negative 2, 0. Cross at negative 2 and at negative 4, and it does have a stretch factor of 2, so that one fits. We're down to the next two. Right here, we can look at this one. That would be 4, 0, and that would be 2, 0. Those would be over on this side of the graph. So we know that that one does not fit. Now for the standard form, we'd have to go negative b over 2a. Negative b is negative 12 over 2 times 2, which would be negative 12 over 4, which is negative 3, and that is our axis of symmetry. So our chances are very good that this one's correct. We put negative 3 in there. Negative 3 squared is 9. 2 times 9 is 18. Negative 3 times 12 is negative 36. Remember, these are always opposites. And half the size of the second one. So it becomes a negative 18 there, plus 16. So that's what's in the equation. Negative 18 plus 16 is negative 2, so it does match the vertex. We can assume it's the right graph then. Okay, number 9. This one is major for testing. I really like you guys to think through your transformations, how you switch from one form to another. Transform the function x squared plus 2x minus 8 into a specified form. Graph it, answer question above. The graph. Okay, so we're going to transform this, this standard form into intercept form. To go to intercept, remember, intercept has the 2 parentheses. So we're just playing the x game. What two numbers multiply to be negative 8, add to be negative 2, or positive 2, I guess it is. If you said positive 4 and negative 2, you're right. And now, just put f of x over here. And now we'd go ahead and graph this. We have x-intercept of negative 4, 0, and 2, 0. So we come down and we mark those. Now we find halfway in between. We can either take negative 4 plus 2 divided by 2. That would be negative 2 over 2, which is negative 1. Or you could actually come up to the graph and you could just count over 1, 1, 2, 2, 3, 3. Okay? Now, in order to find the y value in the vertex, we take this negative 1 and we plug it back into the equation. I would plug it into probably my factored forms. So negative 1 plus 4 is 3. Negative 1 minus 2 is negative 3. They usually are always opposites. So 3 times negative 3 would be negative 9. Okay, assuming that that's at negative 9. I didn't count it, I'm trying to watch my film time. Okay, now the question is, what are the advantages of using this form? X-intercepts are visible, and oftentimes solutions. Okay, because we always look at the solutions of an equation being where it crosses the x-axis. Okay, vertex form. In order to go to vertex form, we have to complete the square. So we have x squared plus 2x minus 8. Picture this in your mind's eye. You've got your x squared, and you've got two x's. You're going to split them in half, get 1, and you square that. So 1 and 1 squared is 1, and there's just one piece that you have to add. So we come down to, put the y there, y plus blank, because we're going to complete our square, we're going to add that piece in, x squared plus 2x plus blank minus 8. Put the 1 in there. That's the one piece to complete that square when we move that one. So, what we add to one side, we add to the other. Now we make it into the perfect square, because that's an x plus 1 times x plus 1. So we have x plus 1 squared. Don't forget to bring that minus 8 down. Y plus 1 equals. Now we need to get the y alone for graphing purposes. So we have y equals x plus 1 squared. Subtract 1 from that side, 1 from that side, we would have a negative 9. If you remember right, that's what our vertex was over on this side. It was negative 1, negative 9. So again, negative 1, negative 9. I meant to put a 10 by 10 grid. It looks a little bit small, so if that's not at negative 1 or at negative 9, realize we do want to count it down to negative 9. I just also want to keep it for this purpose on the graph. So that's our vertex, and we're stretched by 1, so we know to go right through that 1, 1. Okay, next page. If you're wanting instruction, make sure to go back to the notes. You've skipped some of the notes, most likely, or some of the tutoring times that you should have been in on. The graph of the quadratic function, x plus 1 squared plus 6, is translated 4 units to the left. We know left goes positive in here, so put a plus 4. 8 units down, that would be a negative. And now you just add them. X plus 1 and plus 4 would be plus 5 squared. And 6 minus 8 would be a negative 2. And there it is. Okay. Raina is building a walkway around a rectangular pool. Ooh, I always start by drawing these. The pool has a length of 20 and a width of 15. And the walkway has a width of x. So it's x width here, and x width here, x width here, and x width here. Okay, draw a picture and label all the parts. We've done that. Write a quadratic function in standard form for the total area covered. Well, in order to find the area, we need to do length times width equals area. We have to go backwards and kind of figure out what's our width. If this is 15 and we've got an x here and an x there, we should get that it's 2x's plus 15. Lots of ways to write that. Here we have an x, 20, and an x, so it would be 2x's plus 20. Now to get the area, we'd just FOIL those. 2x plus 15, 2x plus 20. We come out with 4x squared plus 70x plus 300. Okay, calculate the area of the sidewalk using 3. In other words, we decided that the walkway will be 3 feet wide, so we're going to plug 3 in for x. And that's what it represents. Walkway is 3 feet wide, giving it a total area of, now we'll figure that out in just a second here. Take our length times our width, FOIL it. Oh, you already got that. Now we plug 3 in for the x. So 4 times 3 squared plus 70 times 3 plus 300. Pretty good sized pool. So now with the sidewalk on the outside of it, it's 12 I'm sorry. It is 9 squared, which is, 3 squared, which is 9, times 4 is 36, plus 210, plus 300. 36 plus 210 is 246, plus 300 is 546 feet squared. So you'd write that over here, equals 546 feet squared. Okay. I'll pause there and I'll come back for part 2.